I chose to do my project over the Svalbard seed vault with respect to storage and climate change. So what is the Svalbard seed vault? It's in Norway, in Svalbard. The Global Seed Vault is the largest structure dedicated to storing seeds on the planet. The subsurface building was constructed in June of 2006 to protect the world's plant genetic material by keeping a duplicate in dormancy conditions. It currently holds a little over 1 million seed samples, and it is buried nearly 400 feet below the surface. And the vault is kept cool with the help of the permafrost and backup generators, keeping the 3 rooms at negative 18 degrees Celsius or 0 degrees Fahrenheit. Each room is about 90 feet long, 30 feet wide, and 20 foot tall. Various countries can deposit seeds of their predominant crops and are the only ones allowed to pull from the stock they supplied from in the first place, so they maintain complete ownership over those seeds. So why is this important? Svalbard serves a very important role that hadn't been filled prior to that June 2006. It holds seeds from all over the world as the first global seed vault in the case of an emergency. While it gives priority to food-producing crops, it actively avoids hybrids in an attempt to preserve the stock species of food crops for later hybridization if needed. In holding these large amounts of valuable genetic material, it is a holding tank for countries' food crop seeds in the case of an emergency. Other seed storage facilities are exposed to the elements and would be much more vulnerable in the event of a weather or energy emergency, rendering all their seeds useless. Svalbard would keep an extra backup stock to replenish these smaller local vaults, and in fact, Aleppo, Syria had to request a portion of their seed contribution back following a natural disaster in 2015, and they had to set these back up in Morocco and Lebanon as well. So how are they stored? Seeds, there's a couple different types of seeds. There's orthodox, intermediate, and recalcitrant, with orthodox seeds lasting longer in storage conditions similar to the global seed bank than recalcitrant seeds. Orthodox seeds need to be dried quickly to a water content of 12%, and they prefer storage conditions that offer extremely low temperatures like those of Svalbard and relative humidity between 10 and 25%. Luckily, most food crops are orthodox and can be stored for nearly 60 years depending on the species in normal conditions. In the Svalbard seed vault, there has been documented viable seed storage lasting 2 to 3 times that of the normally stored seeds. Svalbard stores seeds in sealed boxes on shelving units with extremely low moisture levels and temperatures to slow their metabolic activity, effectively lengthening their shelf life. So, one of the main issues with Svalbard is climate change, and particularly in the Arctic. And the Arctic has been hit harder than the rest of the world in the recent 30 years. And the event has been documented as Arctic amplification. Aside from the loss of habitat, zone changes, and the general temperature swings, the permafrost is starting to melt. And this directly affects Svalbard as the main source of temperature control is the hundreds of feet of permafrost it's buried under. Svalbard was chosen as a part of the world to house the global plant genetic supply due to the calm political climate, remoteness, safety from natural disasters, and most importantly, its ability to be energy efficient from the surrounding temperatures underground. The loss of this natural geothermal cooling would result in an extreme energy cost, which is exactly what Svalbard was trying to benefit from in the first place. Other issues. There have been a few studies done indicating that the data and methods used to dry these seeds down is old and could create longer lasting specimens with new data. One example would be the data collected in 1994 on rice storage, and it was found as recently as 2018 to be inaccurate, and new research suggests that the rice seeds should be dried down in 10 to 20 degrees Celsius and 10 to 15% relative humidity. This concluded that the mature rice seeds are actually more prone to being damaged in the old literature recommendations of drying down. This was thought to be the case as the old data was formulated to work for a wide range of species and not for individuals. Another couple of issues holding the seed bank back would be the need to manually sort things. Commercial seed producers and testers use automated seed sorting as they have a large volume of seed to work through and are sorting for perfection. This could be done at Svalbard, however, their goal isn't seed uniformity and perfection. As the global backup of seeds' genetic diversity, the automated sorting machines would remove more than just contaminants like vegetation and weed seeds. It would remove wanted genetic diversity from the phenotype of the seeds. And the phenotype would be things like the size, the shape, the color, internal structure through X-ray imaging, and this would be impossible to achieve without some kind of AI. So some areas for future research. So like stated before, the correct seed drying and maturity, humidity and storage data could be pursued, as this would lower the need for frequent replacements. This would further lower the operational costs and support the ability to wait out massive natural disasters lasting years on end if that were to ever happen. This creates another issue, though, as the longer the seeds are away from selective pressure, the less fit they become. Research and resources could be put towards the understanding of how to keep up with environmental pressures if possible. Issues that would be hard to avoid would include major zone changes due to climate shifts, specialized pollinators going extinct, and these scenarios would render Svalbard useless as their seed would no longer survive in their original habitat. A third area for improvement would be the building's structural integrity. In 2017, there was a higher than average heat wave and rainfall than in past years, resulting in a water leak through the front door, irreversibly damaging many seed specimens in the nearest hallway. Just a few hours of suboptimal temperatures can ruin a large portion of the seeds in Svalbard. Internal temperature stability has also been documented during natural events like storms and auroras. And if the vault is to withstand large-scale natural disasters to save global food supply, regular happenings of weather events shouldn't be able to disrupt the stability of the seed vault. These are my references.